It's a great pleasure to introduce Vivienne Ming as our final keynote speaker of the Life Summit 2020. Vivienne?
Wonderful. It's me. It's fun to be back here. So we're going to hear, I guess, about synthetic biology and applications of AI in some truly novel spaces. So I think I'll take 10 minutes and talk about that facet of my work, which is a little different than the last time I visited AI LA, where I was there to talk about the future of work. I remember it clearly because it was the first time in 20 years that I actually missed a flight. I was having so much fun that I was late to LAX. It was the last flight out and I had to sleep on a fucking chair in the airport. But it was worth it meeting with you all. I somehow suspect I wouldn't have the same problem reaching the airport today. Having said that, let's get into some really interesting applications of artificial intelligence. We don't have a ton of time, so I just wanted to focus on two in the domain of bringing the best of what machines can do and brains and life sciences together. So one is a space that's sort of near and dear to all of us right now, simply because it makes use of a technology which has been much in the news, which is contact tracing. I'm sure that for some people out there, the idea of using mobile phones, for example, pinging each other with Bluetooth or pinging each other with hypersonic signals is a really novel one. And a wonderful application of artificial intelligence is being able to mine through that data quickly, and one would hope with respect for privacy, and be able to trace back infections of COVID-19 after they've already, well, of coronavirus, but after that COVID-19 diagnosis has been made. One would imagine there's a simple step, which is assume everyone in the White House is infected. But occasionally you actually need some real machine learning to help you make a decision. So what's interesting to me is this isn't a novel technology. Many years ago, I had a curiosity around education. What happens when the teachers aren't there? What happens when 5-year-old kids that are speaking Spanish at home and English in the classroom are by themselves on the playground? Or for that matter, what sort of language do teenagers use? Or how do undergrads talk to each other on campus? So we actually leveraged some existing contact tracing back then to actually trace conversations as they happened in the world. Needless to say, there is no off-the-shelf language model that lets you hear a 5-year-old little girl's voice speaking in Spanish, English, Spanglish, and every imaginable variation in between. So we had to build it all ourselves, cook it together, and see what we would learn. Years later, I had the chance to take a similar technology and explore. We actually just had a post out about this a couple days ago. This giant company came to me and said, Dr. Ming, what is the single biggest untracked causal factor in productivity in our company? What aren't we paying attention to? It's actually making us bigger and better. So I went through and we used a similar contact tracing technology, in this case, using near field technology, but we were able to forget the org chart and just say, what is the actual social graph of this company? And then we were able to truly mash up humans and deep neural networks. What does BackProc do? It lets you take a whole bunch, maybe millions, perhaps billions of individual units and figure out how their slight variations in functioning, taking information in and putting it out to their neighbors, changes the global operation. So we were able to take essentially some math behind backpropagation, combine it with a form of economics modeling called value-added modeling, and actually model how the behaviors of individual people in this company actually contributed to the global whole. The punchline, which you could read about if you really want to, is the biggest untracked predictor was purpose. It was people that helped other people for no good reason other than that's who they were. Who thought that business worked on something so fundamentally human as altruism and sacrifice, but the companies that are most successful show this. I loved having a finding around the idea of purpose surfaced by using machine learning to mine through masses and masses of data of nearly 500,000 people. So now we're in this world where people are talking about contract tracing, not for strange purposes of education or workforce development, but life and death. And it got me thinking. We saw some really interesting features, like we could predict which people added into a local clique of a social network would actually make that team more innovative or more productive. We saw similar things in work we were doing trying to formulate cohorts, optimal learning cohorts. Turns out it's a combinatorics nightmare, but you can really make progress on a problem like that, both of which were predictive. Who could we bring in to a social network to make it better? Well, what is the corollary for coronavirus? Well, it turns out there's a ton of research out there, not using machine learning, for looking at how you can apply medical interventions, such as prophylactic vaccinations, in contexts where you don't have enough to go around. Say, for example, parasitic worms in Africa. So this analysis was done showing that you could actually identify optimal individuals. And if you prophylactically trained or vaccinated them, you actually had substantially lower R0 transmission rates than if you went in and just did it by intuition. Say you prepped or trained all the village leaders and the nurses that were coming in. No, there were certain people that were central to the graph. So we thought we should do the same thing. What if we took social network information and looked at it through the context of COVID-19? One of the recurring findings of recent months has been that nearly 70% of infected individuals go on to infect 0 other people, not a single new infection. So in fact, somewhere between 10 and 20% of all new infections, of all existing infections, produce virtually all of the new ones. So coronavirus is a super spreader disease, or maybe super spreader is overputting it, but it's at least a classic 80-20. 20% of the people are causing 80% of the new infections. What if, a la Minority Report, here's a quick quiz. Are you nerd enough to know why it's called Minority Report? All right, back to the program. What we did was actually analyze this information and look to see what are the characteristics of people that are likely to transmit. What are they in their social graphs? And it turns out you can not only look at people, but places. So you can put places and people into the same social graph and then analyze it prophylactically to look at who is likely and where is likely to become the source of new outbreaks. And unsurprisingly, one of the greatest sources is the fact that we don't pay our elder care workers enough. So if you are trained in elder care and you don't have enough money to pay your rent, what are you going to do? You're going to work at another elder care facility or with another patient. So one of the principal potential spreaders are people who are very innocently just trying to pay their rent and feed their families, hopping on mass transit, getting exposed, and then taking it from one elder care or intensive care facility to another. In fact, an analysis, a social graph analysis done by us, found that every care facility was socially connected to at least 17 other facilities on average. It's like a recipe for mortality. And unfortunately, we've seen this again and again in the United States, and also in other places, in Sweden and in Canada, that this has been the principal source. Wouldn't it be amazing if we could go in ahead of time and simply pay people to either stay home or, even better, pay them to bubble up with their care? You're gonna spend a month in, and we're gonna triple your salary, quintuple. Do you think that's expensive? It's cost us $15 trillion from the US economy because of our current response to COVID. Using the judicious application of some relatively straightforward machine learning, we could actually dramatically reduce that while increasing our protection of the people that are most at risk. I'm almost out of time already, but that was one application. And another, I get to sit on a whole bunch of boards. And in fact, I stupidly just founded a whole new company in neurotechnologies and biotechnologies. I love the field because, again, I get to treat my nerd-tastic love of data and artificial intelligence and mash it up with my actual degrees in neuroscience and say what is possible. We are looking right now at phasic therapeutic light therapies for neurodegeneration and Alzheimer's, for example, or in another one of my companies using theta rate augmentation, synchronization technologies to potentially treat traumatic brain injuries in children. And one of the most exciting domains in all of this work, including another startup working with people that are locked in, allowing them to communicate outside of their bodies, is the closing of the loop. It was not possible before the rise of deep neural networks for us to truly take what's called one-shot looks at things like EEG, electrocardiogram, brainwaves, and turn it into something meaningful. And now we're able to do things like conversational translations of basic words that people are imagining so that they're locked in, they can still communicate with the outside world. But we're also looking at fine-tuning that synchronous theta oscillations so that you're really linking up frontal and posterior. If you don't know what I'm talking about, all I can say is we're taking some of the best of what makes machines truly amazing and combine it with something that already is amazing, which is us. And we lose track of that so often. The value of AI is that creative people like all of you can use it as a tool to solve problems. And I believe in our next session, we're going to hear from a panel of people that are using these sorts of tools in synthetic biology. I just want to emphasize, though, for everything you've heard over the last 2 years, cool new papers, new architectures, optimizations around hyperparameters, I want you to remember, as much fun as that is, and how much we love to geek out about the new paper on how reinforcement learning is actual model optimization along with data optimization, an actual new paper. I highly recommend it from UC Berkeley. It is you that solves problems. And AI does not work if human beings aren't being the creative core of this process. So please stick around and hear about how people are solving some of the most pressing issues in biology for the rest of our session today.